Everyone. In this video, we will be discussing the human water cycle and how humans interact with water. This video assumes that you already have knowledge about the water cycle. How humans interact with water is part 1 of this video, and part 2 discusses the wastewater treatment process. Andrew Copley is the original creator of this lesson plan. Support for development of this lesson plan is given by the NSF through funding of the Boat of Knowledge in the Science Classroom project at Ohio University. Have you ever wondered where your water comes from and where it goes? In the modern era, we are spoiled by extremely easy access to water. Turn on the tap and water magically appears. Flush a toilet and the water disappears. Behind the scenes, a complicated network of water infrastructure is in place which allows for this magic to happen. People living in the country may be more in tune with their water resource since it's probably pumped from a private well located on their property. But for people living in urban areas or small towns, the source of water is less certain. Where does this water come from? How does it get to people's homes? What needs to be done in order for that water to be drinkable? And what happens to it after it's been used? As the public becomes increasingly more knowledgeable as water consumers, these questions have become more important in recent years. Water sources can be divided into 2 main camps: groundwater resources and surface water resources. Direct rainwater collection or dew harvesting could also be considered, but these sources are far less practical on a larger scale. Groundwater is water stored underground in aquifers. Surface water is water which flows freely in rivers, streams, and lakes. Whether you receive water from one resource or the other depends largely on the state of the water resources. Considerations typically include whether the water is clean, easy to access, consistently available, plentiful, and if there is water infrastructure in place to acquire it. Of the 2.5% of fresh water on Earth, roughly 68.7% is preserved in glaciers, 30% is groundwater, and less than 1% is in surface water. Most communities utilize groundwater because it is in greater supply, is generally safer, and is not limited to the presence of rivers and streams. Water resources are commonly defined by the watersheds where they are found. A watershed, or river basin, is simply a large area of land where all water is drained to a single point, such as a river, stream, lake, or ocean. Larger watersheds are comprised of smaller sub-basins, which make up the whole. In the United States, the largest watershed is the Mississippi River Basin, which covers nearly 41% of the contiguous United States and supplies roughly 18 million people with water. Over this large area, all of the water which is captured in the rivers and streams therein will find its way to the Gulf of Mexico through the Mississippi River. To illustrate how water drains through a watershed and the connectedness between sub-basins and larger basins, let's get a closer look at different points along the Mississippi River. Lake Itasca serves as the headwaters of the Mississippi, where the river ultimately begins. The flow of water in the upper Mississippi River is low because little water has been captured at this point. As the Mississippi meanders south, it captures smaller rivers and streams until it eventually meets at the confluence of the Ohio River in Indiana. At this point, since the Ohio River conveys more water than the Mississippi more than doubles in size. The Mississippi continues south, getting larger until it drains into the Gulf of Mexico. The discharge of water into the Gulf of Mexico is, on average, around 200 to 700,000 cubic feet per second. This is a substantial amount of water, accounting for roughly 40% of the contiguous United States. The Mississippi River Basin, and all river basins, can be thought of as a large funnel. Water from a large area is concentrated and drains to a central point. Do you know which river basin you belong to? The river basin which is local to Ohio University is the Hocking River Basin. The Hocking River Basin extends across 5 counties and ultimately conveys water within the Hocking River to a confluence point in the Ohio River. This means that the Hocking River Basin is a sub-basin to the Ohio River Basin, and by extension the Mississippi River Basin. Most of the water withdrawn by municipalities and other entities in the Hocking River Basin utilize groundwater, about 86.6%, which is partly due to the poor quality of the Hocking River and surrounding tributaries. So why is any of this important? Our water resources are connected in a highly sensitive system of waterways and underground aquifers. A chemical spill upstream may affect the water quality downstream. Improperly disposing of waste or poor treatment of wastewater could cause unintended problems for others. For a recent example, in June of 2016, drinking water for select locations in the Columbus area was high in nitrate concentration. Excess runoff in the agriculturally intensive northern part of the Scioto River Basin introduced high levels of nitrate fertilizer into the city's water reservoirs. As a result, Columbus issued a nitrate advisory warning for areas served by the polluted reservoirs. While moderate quantities of nitrate aren't exactly harmful for adults, young children and infants may become ill and possibly die if they ingest too much. Pregnant women were advised not to drink this water. This is why proper treatment of our water and wastewater is extremely important. We are able to confidently drink water from the tap without ever having to worry about any negative consequences. As humans find new uses for water, it is imperative to restore the water to an acceptable level for possible reuse in the future. This marks the end of Part 1. Before moving on to Part 2, visit the EPA website shown to take a virtual tour of a water treatment plant. This video serves as a good introduction as to why we treat water, the basics of water treatment for drinking water, and individual processes used in a typical water treatment plant. You may also watch the book's drinking water process video to learn more in-depth information on the treatment of drinking water.